Okay, this video is going to go over on how to graph a piecewise function. This is just an introduction. We will be adding additional functions as we move through the unit. A piecewise function is nothing more than a function that's made up of two or more pieces. And when we do that, instead of having a domain for the entire function, we have to have a function called a subfunction here, or a piece, and its domain called a subdomain. So for instance, in this one, my first piece is the function, or my subfunction is x plus 4 squared. Its subdomain that goes with it is x is less than negative 4. My second piece is x plus 2, and the subdomain that goes with it is x is greater than or equal to negative 4. On the right-hand side, we have a three-piece piecewise function. And so again, I have three pieces. My first piece is this function here with its related subdomain. The second piece is this function here with its related subdomain. And its third piece is this piece here with its related subdomain. And so when we come to graphing a piecewise function, the first thing we need to know is how many pieces it's going to have. And so the number of pieces that we're going to see both in the function and the graph should relate. So for instance, this function on the left has two pieces. When we graph it in a little bit, we're going to see that it has two distinct pieces on the graph. The one on the right has three pieces, and we're going to see that when we graph it, it will have three distinct pieces on the graph. So the second part to this is, or the second step, I should say, is draw a table for each function, that is subfunction, and identify the x values needed. So I've done tables, or I've created tables for the two pieces and the three pieces, and I've set them up below. So as you can see, for the two-piece function, I have two tables, one for each piece. And for the three-piece function, I have a table for each piece. Now, I've already put x values into these tables, but I want to talk a little bit about how you go about putting your x values in when you're doing one on your own. So we see that our first subdomain is that x has to be less than negative 4, and our second one is that x has to be greater than or equal to negative 4. So what I'm going to do, since that first subdomain says that x has to be less than negative 4, I put negative 4 at the bottom of my table, and then I'm going to work up putting values that are less than negative 4. So since my boundary for that first piece, or the end point for that first piece, is going to be negative 4, and everything has to be less than it, I'm going to put it at the bottom, and then my other values are negative 5, negative 6, negative 7, negative 8, because those values are less than. For the second piece, it says x has to be greater than or equal to negative 4. Since they have to be greater than, I'm going to put the negative 4 at the top, and I'm going to complete my table with numbers that are greater than negative 4. In this case, negative 3, negative 2, negative 1, 0. Now, a word on this, the number of points you have to have in your table is completely up to you. When we get to the graphing piece, you'll see you may need more points to determine what type of graph you're looking at. Now, in our three-piece function, I start with the first one, and I see that my subdomain reads x is less than negative 1. So I put negative 1 at the bottom, and values, I filled the rest of the table in with values that are less than negative 1. So negative 2, negative 3, negative 4, negative 5. The middle piece's subdomain reads negative 1 is less than or equal to x is less than 3. So we know our x values here have to be between my endpoints of negative 1 and positive 3. So I start this table with negative 1, I end it with 3, and I put all the integers that are in between them. And then finally, for my third piece, we see the subdomain here in blue is x is greater than or equal to 3. So my last table, I'm going to start with a value of 3, and then I need numbers that are greater than 3. So I put in 4, 5, 6, and 7. So, and again, you may need more points to understand what type of graph it is when we get to the graphing piece. So that's step 2, draw a table for each function, identify the x values needed. Again, these tables, when you get to doing practice problems, will not be provided for you. You'll have to create your own tables and decide on what x values you need. Step 3, what we're going to do is we're going to use our calculator to fill in the tables. So we're going to use our calculator or Desmos, which I prefer as my calculator, and fill in the y values for these tables based on the subfunctions and the x values that we've picked here in step 2. Once I've got the y values filled in, then I'm going to go back to my endpoints that were specified in the subdomains, like in the 2 piece, the -4, and the 3 piece, that would be the -1, the 3, and the 3. And we need to determine, should we have an open circle on our graph there or a closed circle? And the only difference is if the subdomain states that x is strictly less than or greater than, then that point deserves an open circle. However, if it can be equal to that x value, then we'll use a closed circle there. And once I've got that determined, I'm going to plot my points and I'm going to connect my graph. So let's go ahead and complete the 2 piece and the 3 piece piecewise functions. I'm going to walk us through. We already know that there's 2 pieces for this, and we know there's 3 pieces. And so I have 2 tables for the 2 piece, 3 tables for the 3 piece. And so we're going to walk through the process of filling in the y values. Then we're going to determine whether the endpoint should be solid circles or open circles. And then we'll go ahead and graph our points and get our graphs on the page. So let's go ahead and go to Desmos. And what we're going to do in Desmos is we're going to put in these functions. And I'm going to show you how to get the y values for each function so we can complete our tables. So we're going to go over to Desmos here. There we go. And so in Desmos, I'm just going to type in each of my functions. So I have x plus 4 squared. That's my first subfunction. And then I have x plus 2. And so if you look at the Desmos window, those are the 2 graphs that I'm regraphing. However, we're not going to see all of both graphs. So what I'm going to do now to get my y values that need to go on my table is I'm going to come up here and I'm going to click the gear. And then I'm going to look for this table, create table option. So I'm going to create a table for my green one. And then I'm going to come back down and click the gear again. I'm going to create a table for the purple one. So the green one here is my first piece. It's the x plus 4 squared. But when I look at my table, I do not need -2, -1, 0, 1, and 2. The table that's on my graphic organizer and the x values that we picked start at -8. Well, all I have to do in Desmos is type in those values. So I've got -8, then I had -7, -6, -5, and -4. And so these are going to be the y values that I need in my table for me to go ahead and graph. So I'm going to go ahead and transfer those over. So we're going to have 16. We got 16, 9, 4, 1, and 0. So I'm just filling in my table with my y values. And so this table, again, just in case you're wondering, corresponds to, I'm going to use blue this time because I wrote the y values in blue, corresponds to this function right here. Now this next function, I will use pink for my y values, and so we're corresponding to this function here. So I'm going back to Desmos. I'm going to come to my second piece. And again, the x values aren't what I need. So I'm going to change the x values. I'm going to give it -4, -3, -2, -1, and 0. And so here again, we can see the y values that we're going to need. So I'm going to come back, and there we go. And so I'm going to put these y values in. They start at -2 and go to +2. So I'm going to have -2, -1, 0, 1, and 2. So I've identified how many pieces I'm going to have. I've created tables. Now, again, tables will not be provided for you on future problems, like practice problems, you'll have to create the tables yourself and decide on your x values. But we've now finished the tables. My fourth step is to determine whether my endpoint should have solid or open circles. So looking at this first piece, I see that the subdomain states that x has to be strictly less than -4. So what that means is down here at -4 for this one, this -4 here is going to have a closed circle. While in my second piece, I can see that the -4, it has to be greater than or equal to -4. And that is incorrect. I'm sorry. Since it was strictly less than, I apologize. This -4 should have an open circle. My closed circle is going to come up here with the pink piece. And so this one's going to have a solid circle. And all that is to remind us what our endpoints are going to look like. Now, some students also find it helpful when they see ones like this and there's only one endpoint in the subdomain for the other end to put an arrow to remind themselves that it goes on forever. So like, for instance, on the upper part of that one, I'm going to put an arrow. On the bottom part of this one, I'm going to put an arrow. All right. Now all we need to do is we need to take and transfer these points to our graph. So we're going to plot our points, and then we're going to connect them, once I know what type of function is, with a nice smooth curve. And I'm going to put my open circle and my closed circle on there, and then I need to remember to put arrows on the other ends. So let's go ahead and do that. So we've got graphs here. I'm going to change back to blue to do our first part. So notice -8, 16, well, that point's off of my graph because my graph only goes up to 10. So I'm going to ignore that point. And I'm going to go with -7, +9. So I come over here to x equals -7. I'm going to go up to +9, and we're going to have a point there. Now I'm not going to make it a big point because I'm going to be connecting that one in a little bit. Then let's see, we had -6, +4. So -6, +4, another little point there. Then we had -5, +1, another little point here. And then we had -4, 0. Now this one we had indicated needed to be an open circle. So I'm going to exaggerate that one a little bit because I want it to be clear to somebody looking at the graph that that value is not included. And now, so I know there's a couple of things where I can know what the shape of this graph is. I could either graph more points if I had my graph extended or maybe a different scale, or I can also look at this equation and realize that it's a quadratic, and so my graph should be a parabola. And so in a similar manner, I can look at the pink piece I'm about to graph, and I can see that this is going to be a linear function, and so that my graph is going to be a line. Now, I don't know exactly where the line is going to be located. That's what we're going to use our y values for. So we're going to come in, and our first point is going to be at -4, -2. So I'm coming in just under where I had my open circle, but these two pieces are not connected, and I have a solid point there. And then my other points are going to be at -3, -1. Again, a small point because I'm going to connect these in a minute. -2, 0. Let's see, -1, +1, and at 0, 2. And again, I'm going to use a small point because notice I have an arrow here, which lets me know that this thing is going to go on forever. So again, this one is a linear function, meaning its graph's just going to be a straight line. And there's my graph. So I got a slight curve here in my quadratic because eventually it'd be a parabola and come around this way, whereas this one is just a line going that way. If I did not have that subdomain, it would also go to the left. So let's go ahead and take a look at this three-piece function. So I'm going to color code my pieces again. I'm going to make the first piece blue. Let's make the second piece pink. And let's make the third piece green. All right. That way we can see it in our tables, and we'll be able to see it on our graph when we get there. So now again, the thing I need to do is I'm going to go over to Desmos, and I'm going to put all three of these pieces in. Now, I'm not so much worried about the color in Desmos because Desmos has its colors, and I can change them a little bit, but pink is not an option here in Desmos. So I'm going to put in that first piece, -x - 1. I'm going to put in the second piece, x² - 4. And then I'm going to put in the third piece, the quantity x minus 4 squared. Right? So there's my three pieces. I'm going to come back. I'm going to ask each one to be turned into a table by clicking on the gear. Okay. Now, more than likely, again, Desmos always defaults to x values of -2 to 2 because it doesn't know. So we always have to go in and adjust these unless it turns out to be exactly the points we want. So I'm going to have -5, -4, -3, -2, -1. And again, for right now, I'm just getting those from this table right here. But again, the tables will not be provided for you. You're going to have to create your own tables. For the second piece, for -x, nope, that's the first piece. I apologize. Here we go, our second piece. Instead of -2, I want to have a -1 there. Oops, I said -1, didn't type it. -1, 0, 1, 2, 3. And so I have my y values for that second piece. And now I need to go on to my third and final piece. I don't need a -2 in there. I need a 3, a 4, 5, 6, and 7. But as I type those, it updates the y value based on the function that we have above. All right. So now what I'm going to do is I'm going to take this information from Desmos and transfer it back to my tables on my graphic organizer. So we're going to start with blue. So I'm going to come back here and select my blue pen. And it looked like these were 4, 3, 2, 1, and 0 from Desmos. And so I can see them here, 4, 3, 2, 1, 0. For my second piece, I have -3, -4, -3, 0, 5. So I'm going to come in, I'm going to select my pink pen. And so we have -3, -4, -3, 0, and 5. For my third and final piece, I'll need the green pen. So let's get that selected. There we go. And so for my third piece, I'll see that I have 1, 0, 1, 4, 9. So I have 1, 0, 1, 4, 9. And so now I just need to come back and look at my endpoints for each subdomain and determine whether I should have an open or a closed circle. So in this first domain, it just tells me that x has to be less than -1. So that means I'm going to come to my -1. And since it has to be strictly less than, I'm going to have an open circle there. And because I don't have another endpoint, that means there's going to be an arrow going that opposite way. Now in this middle piece, however, my subdomain has two endpoints, -1 and 3. So here I have that -1 has to be less than or equal to x. So that means for this one, we're going to have a closed or a filled in circle. And then it reads that x has to be less than 3. Since this has to be strictly less than, we're going to have an open circle there. And then we get to our third and final piece here in green, and it tells me that x has to be greater than or equal to 3. So since it can be equal to that, we're going to have a closed circle. And since there's not a second endpoint, I'm going to put an arrow away from it, letting me know that it's going to go on forever. Now that I have my y tables completed, or my y values completed in my tables, I should say, and I have my endpoints decided as being open or closed circles, I'm ready to graph. So I'm going to go back and I'm going to start with that first piece. And so we have -5, +4. So I've got -5, +4. And I'm going to put just a small point there because we can see that we should have an arrow on that end. Then we're going to have -4, +3. So I have -4, +3, another small point. I have -3, +2, another small point. -2, +1, small point. -1, 0. Now for this one, we've indicated that there should be an open circle there. And so looks like here that it's going to be a linear function. I can go back and look at my subfunction. Indeed, it is a linear function. So this one's just going to be a line. So I'm going to come in and make what I hope ends up being a somewhat straight line. There we go. So I've got that line. Now I'm going to go to my middle piece, which is going to be in pink. And so it needs to start at -1, -3. So we're going to come down from -1 and go to -3. And as we can see indicated up there, it's supposed to have a solid point there. So I'm going to exaggerate a little bit so that everybody can see it. And then I'm going to go to 0, -4, so a small point there. Then I come to 1, -3, then 2, 0. And then +3 is at +5, but it needs to have an open circle. Now this one I can kind of see the parabolic shape, and then I can also go back and verify, yep, it's a quadratic, so I'm going to have a parabola here. So I'm going to start here at my closed point and come around to my open point, because I know it's supposed to be a parabola. And then for my third and final piece, again, I've got these values here, so I'm going to go ahead and plot those. So I'm going to have 3, +1, and it indicates there in my table that I should have a solid point here. And then at 4, I'm going to have a value of 0. At 5, I'm going to have a value of 1. And at 6, I'll have a value of 4. And then at 7, I have a value of 9. And I can see that there's an arrow there. So that means this one's going to go ahead and go on forever. All right. So again, I can see it's a parabola. If I look at the function, I can tell it's a quadratic function. And so I'm going to sketch in hopefully something that looks like a parabola. And I'm going to put an arrow on the end of it to indicate that it keeps on going. And so there's the graph for my 3-piece piecewise function. So again, the steps: determine how many pieces you have, create a table of values, and decide what X values you're going to use in your tables. Again, there should be one table per piece. Once you've got your tables created with your X values, use either Desmos or your calculator to get your Y values. Fourth, determine whether your endpoints should be open or closed circles. And I also like to add in arrows for things that do not have an endpoint. And once you have all that done, then just plot your points, paying attention to your open closed circles, and connect your graphs with a smooth curve or a line. That concludes this video on how to graph piecewise functions.